Welcome to the Explainer. Today we're tackling a cyber attack that's, believe it or not, been around for more than 20 years. And yet, it's still one of the most dangerous and frankly most common threats you'll find on the web. We're talking about SQL injection. So let's kick things off with a little puzzle. How can a totally innocent-looking text box, like a login field or a search bar, be turned into a key that unlocks a company's entire database, passwords and all? It sounds like fiction, but I promise you it's not.
The technique behind this is called SQL injection. At its core, it's a way of tricking a website. An attacker writes a little piece of a database command and hides it inside what looks like normal data. The website's application then accidentally runs that malicious code, doing things it was never, ever supposed to do.
And just to be clear, we're not talking about some obscure theoretical problem here. According to the Open Web Application Security Project, that's OWASP for short, injection attacks like this are consistently ranked as the #1 most critical security risk for web apps. For years, it's been right at the top of their list.
So what is it? What's the fundamental flaw that makes this whole thing possible? Well, it all boils down to one simple and very human idea: trust.
Here's where the problem starts. A lot of older, or just poorly written code takes its own commands and literally just glues them together with whatever a user types in. It builds one long sentence, one string of text. This mixing of what the computer is supposed to do with what the user says, that's the original sin. That's the crack in the armor.
Okay, so let's get our hands dirty and see how a hacker actually takes advantage of this misplaced trust. We're going to walk through a real attack step by step.
For this, we're going to use something called the Damn Vulnerable Web Application. It's a tool made specifically for practicing this stuff. And look, when you use it normally, it works exactly like you'd think. You put in the user ID 1, hit submit, and it brings back the info for user number 1. So far, so good, right?
But see, an attacker isn't here to play by the rules. They're not going to give it a simple number. No, they're going to craft a very specific, very clever piece of text that's designed to break the logic of the code running on the back end.
And here it is. This is a classic. It's called an always true attack. The attacker types in this little phrase. That first little apostrophe is key. It closes off the part where the user ID was supposed to go. And everything after it, well, that becomes part of the command itself. So now the database is being asked, hey, find me user where the ID is empty or where 1 equals 1. And since 1 always equals 1, the database just says, okay, and dumps out every single user it has.
But just getting past a login screen, that's child's play. The real prize is the data. And for that, attackers have an even more powerful tool. It's a command called union select, and it lets them basically staple their own, totally separate malicious request right onto the original legitimate one.
And this, right here, this is the jackpot. Using that union select, the attacker is now telling the database, hey, after you do your thing, I also want you to grab me the usernames and passwords from the users table. And the database, not knowing any better, just does it. It spits out the entire list of user accounts and their password hashes right there on the screen for the attacker to see. Game over.
Now, when a developer sees this, their first instinct is usually, okay, I'll just block the bad words, I'll filter out the word union or the apostrophe character. But this is a total losing game.
Trying to blacklist bad words turns security into this endless game of cat and mouse. An attacker can always find a new way to write their query, a new way to encode it to bypass the filter. But the biggest problem? It's human. All it takes is for one developer on one team to forget to add that filter to just one single input box on a massive website, and the entire system is vulnerable all over again. We found this quote in a Hungarian developer guide, and it just captures the feeling perfectly. After explaining why trying to filter stuff out will never work, the author just writes, Sohaj, sajnos ez sem elég, which translates to sigh. Unfortunately, this isn't enough either. And that sigh, it says it all, doesn't it? It's the sound of pure frustration.
So, if playing that cat and mouse game is the wrong way, what's the right way? What's the winning move? Well, luckily, the correct solution is incredibly elegant, and it's been a standard part of programming for decades.
Okay, check this out. The solution is called prepared statements, or sometimes parameterized queries.
The magic here is that you completely separate the command from the data. Instead of mashing them together, you send them in two different steps. First, you send the command template to the database with a little placeholder, that question mark, where the data is supposed to go.
And this is the genius of it. The database gets the command, sees its structure, and compiles it before it ever even sees what the user typed in. Then, in a second separate step, you send the user's data. The database just takes that data and safely plugs it into the placeholder it already knows about. The data is just data. It is never, ever mistaken for a command. The attack just fizzles. It can't work.
So, this technique completely solves SQL injection. It's built right into every modern programming language. It's simple, it's secure. So, why are we still talking about it? Why is it still #1 on the charts?
Well, this brings us to the really important takeaways. Number 1, never, ever, ever trust user input. Period. Number 2, don't build your database queries by hand. And 3, always, always use prepared statements. This is one of the most dangerous security flaws out there, but it's also one of the most preventable. In a perfect world, it shouldn't even exist in new applications today.
And that leaves us with one last big question. In a world where we have such a simple, well-known, and robust solution, why does this problem continue to plague the internet? Why is it still the top vulnerability? And the answer really isn't about technology. It's about people. It's about old, legacy code that no one wants to touch. It's about gaps in developer education. And it's about the constant pressure to just ship things fast, even if it means not shipping them securely.